Okay, we'd like to get started. This next session, the summary session, includes the working group outbriefs as well as a summary of the conference and the closing remarks. So we're going to go down through the working groups in order, and we'll go ahead now.
Testing? All right. Let's see, I'm Ryan Noguchi. We had a great session yesterday on model-based systems and software engineering. We had about 24 people show up, and we had a great, lively discussion. We talked about a variety of things, focusing primarily on model-based systems engineering based on the interest of the folks who showed up. We talked a little about model-based software engineering, but it was mostly a model-based systems engineering crowd. We didn't have any panelists or presenters, but these are some of the key points, kind of how the discussion wandered and meandered throughout the day, and where we kind of lingered and had a lot of our discussion in. We talked a lot about the modeling process and how that really helps us to ferret out those inconsistencies that arise whenever you develop a large complex system with a huge team of people, that everyone has a different mental model of what's going on, and there are a lot of gaps in that knowledge, a lot of inconsistencies between folks' mental models. We talked about how use cases and mission threads can help us to, as you develop those and model those to architect your system, you can use those throughout the development process to guide and drive your V&V process. We talked about some different perspectives on visualization, large versus small views and of the model, and also using external tools to be able to better convey the information that you need to get out of the model. We talked a lot about integrating the system models with cost models and some of the challenges involved in kind of that impedance mismatch between what the financial management folks need and what the technical folks need with regard to partitioning your system and so forth. We talked a lot about the challenges that practitioners face in the MBSE world, training and education, cultural challenges, challenges with sharing the model. I mean, you want to use the model as a means of communication, and you'd like to be able to share pieces of that model in order to communicate. But there are a lot of challenges to that. Tool interoperability just isn't there. Standards are evolving, and not everyone's going to be on the same version of that standard at any given time. The ontologies that people are using to develop those models are going to be different. So there's impedance mismatch between folks' models. There are also proprietary and security concerns that can be a big challenge in sharing across those organizational boundaries. And we talked a lot also about the benefits of model-based techniques and a lot of some of those little success stories that really they add up and help provide a strong rationale for incorporating it into your program. And we need more of those to help build that argument that MBSE really is something that we need to move toward for these complex systems. And so some of the key conclusions that we reach are along these lines. I mean, we talked about MBSE as really being essential for helping us to build, develop, and maintain, sustain these complex systems that we're building today, these complex enterprises that we're trying to develop and sustain over a long period of time. We're hoping to never have to develop another ground system again. We need to make sure we do it right the first time and continually update those models to make sure that we are always reflecting the current reality. We recognize also that MBSE is more front-loaded than traditional methods, and that needs to be planned for, it needs to be budgeted for. A lot of that front-end work and training and developing your infrastructure, your configuration management processes and so forth, that all needs to be done up front, but it can pay big dividends on the back end by helping reduce those expensive rework cycles that really drive your schedule and cost. But of course, it's sometimes difficult to demonstrate that ROI by saying, "Oh, we're going to prevent these big rework cycles later." It's hard to demonstrate that up front. But we are seeing a lot of success stories in the upfront world, the front end, where people are being able to use these model-based techniques to help us execute much more effective and comprehensive trade studies early in the life cycle and seeing a lot of benefit there, as well as being able to do impact analysis of changes as your technical baseline is rapidly evolving in that early phase of the life cycle. So we're finding there are a lot of these success stories that people are building up. We just need to make sure that we communicate those and use those to help us strengthen our resolve. Training and education is also a big thing. Not just the people who need to develop the models, but the larger number of people who have to use the models, who have to get their information out of them, and may need to change their processes and their mindset to be able to take advantage of the capabilities that the models and tools provide that they may not have been used to taking advantage of before. And there's a key need for ambassadors who can bridge that gap. between the folks, the modelers, the hardcore modelers, and the larger community of SMEs and stakeholders who need to use that information. And really, the model is about information. It's about capturing the collective knowledge of the community in a consistent manner, and the views that we provide out of the model really are our mechanism for communication. So, thanks.
We're session 11B. Part of our goals were to discuss common issues and challenges regarding the approaches to enterprise transformation and discuss some methods to address them. We had between 50 and 60, depending on whether we were in the garage or here in the ballroom. It was interesting when they turned on the leaf blower out in the garage. This was our panelists. Please note that we had pretty much people from all different types of government organizations that were doing it, with the notable exception of one. We're hoping to get them next year to come out and discuss with us what they're doing. Had a hard time differentiating at 10 p.m. last night, difference between key points and conclusions. So the line that I drew in the sand was key points were more declarative statements, whereas our conclusions would be things that we might need to do in the future. So in terms of key points, culture is a main barrier to acceptance, and the group pretty much agreed on that one there. The one thing that was noted, and is probably true, your younger generation is more amenable to change. Unfortunately, most of your management are more senior folks. And so we have this dynamic balance that's going on, and as Dan was pointing out, the younger generation, those will be here in GSAW 2030, are the ones that we need to be bringing up and raising. Budget cuts drive innovation. Yeah, that's scary, but that was one of the main drivers. If you're happy and you're complacent, you got enough money to do whatever you want to do, you typically aren't going to change what you got. Why bother? It works. And so budget cuts do indeed drive innovation, and with some of the reports that are going on right now with the GAO and other types of things, I wouldn't be surprised to see that lever pulled. Strong, consistent, sustained leadership is required for change. We will not have success without it. The amount of change will be commensurate with the leadership equities that are put in, and that's just the way it's going to be. And so leadership needs to be fully informed that they will have to be active, consistent, and it will have to actually move beyond the changes in leadership that go on for the effects to occur, because this is a multi-year effort. Success is dependent on bringing all stakeholders together early, allowing operators to use the system before it's deployed to be helpful, putting prototypes out on the floor, letting it run shadow ops, and actually have them using the system, have active input into changes before it's deployed. Is one way to bring about the social change that needs to take place. Acquisition agility is going to be essential for delivering meaningful effects to support the warfighter. As we've said many times, this can no longer take multi-years for development. We need to be working on cycles that are a year or less. Well-architected enterprise will enable capabilities we've not even dreamed of yet. I believe it was General Sheridan who made the point in 10 years people would be using these in ways that we've never even imagined. So, what do we need to do? Well, first off, we need to define the enterprise and why we're changing it. What's our goal? What are we trying to optimize around? Okay, is it strictly cost? Well, our senior leadership has kind of hinted that that's not necessarily what they're looking for. They are looking for effects. So, what effects and how do we optimize for it? Develop good metrics and on the need to change, what's wrong with today, and then track changes with metrics. Numbers speak a lot louder than people's thoughts and opinions do. And so being able to track what we need to do and develop metrics for effectively looking at things is important. Build organizational and personnel transition plans for all the people affected by the changes. If you know you're getting displaced by a change, you're probably not going to be a big fan of it. And so the idea is, how do we social engineer these things so that people are still included and moved, but perhaps the roles are changing to something else? Determine what makes this study that we're currently doing in 2015 different from the ones that were done in 2008 and 2011, and were there any lessons learned that we can draw into that? This is not the first time we have looked at doing an architecture, and Dan kind of poked at that with his comment that in 2030 you may still hear the comment that we're we're at the cusp of moving to one. We need to focus on ConOps and understand that a ConOps needs to evolve with the enterprise. We're going to be doing things in ways that we haven't done them before. To assume that we're going to get it right the first time we write it down on paper is probably a bold assumption, perhaps even a bit arrogant. And so let's accept that fact, put something down, but with the idea that it will evolve as we evolve, and as the system matures and we mature in how we understand to run enterprises, that things will change. Provide incentives and motivations for all participants to change the culture. If we're able to do this, the changes will sustain themselves. If not, you will need the ruthless tyrant at the top who is pushing it down. And you're going to need a combination of both, where it's incentive and a way to move forward. We need to prototype and demonstrate to instill confidence. And, oh, by the way, we need to address both real and perceived threats or risks, because perceived risks for people are just as real ones. Anyway, thank you.
So we are from session 11C, and we discussed about the lessons learned on agile ground software development. So we have great list of the participants and contributors from several agile stakeholders' perspective, from vendor, from developers, from government side. So we did have a lively discussion. We have a lot of exchange, a lot of information. So we go through a lot of topics during the discussion. For example, well, how do we do the schedule? How do we do the milestone decision? How do we do the contract? How do we do the source selection? So and so on and so forth. So the outcomes that we have based on our working group. Well, we have identified the issues. So we're asking, well, do you have any question or concern or problems regarding, let's say, source selection or contract? And then we exchange the idea that, okay, well, we did the following thing. This one works. This one did not work. But then there are something that we came up to the conclusion, and then we found that, well, there's a perfect answer for everything. It depends, And, it depends on your organization. We have 10 organizations, and we have 10 answers for that. So there's no one size fits all. So I hope that I could be able to provide you a list of suggestions. But every time we ask a question, the answer is, it depends, right? But anyway, so one thing that I just want to point out is that, well, there are some ongoing problems, kind of risks that we have. There are two kind of topics that we think that we still don't have good suggestions yet. One is the personnel turnover. Well, this guy is going to be promoted, reassigned in 2 years, so what do we do? And then also, usually we don't have a luxury of working on one project at a time. So, and these two problems hurts more in the agile software development because we depend on the tacit knowledge, we depend on the high collaborations. So these two topics are still, usually for other topics we can share tips or tricks. But then when we talk about these two topics, then we talk about, well, okay, we have the same problem. So, so these are something that I think we did a good job. Thank you.
I'm Jim Alstead. I'm co-lead of the workshop 11D on cost estimation for next generation ground systems. My co-lead is Barry Boehm. You want to wave your hand over here, Barry? Okay. We had an intimate and productive working group. We had, about 10 or a dozen people. And the purpose of the working group was to move forward on the development of the COSISMO 3.0 estimating model. That's a model for estimating the cost of system engineering. It's part of a larger effort called COSATMO to estimate the cost of entire satellite systems to help acquirers judge affordability of satellite systems. We had 3 specific goals for our session. to foster two-way communications on COSISMO 3.0. One was Barry and I presented the current COSISMO 3.0 estimating model. Second, we executed a Delphi process to gather expert input on model parameters. So people in the session helped us out by giving their expert input on what the correct model parameters were. And third, we filled in values for an example project. Barry and I each made presentations about the model, and then we went to work. Some of the key points we found was that knowledge about estimating system engineering costs is a specialized field. We didn't have too many people in our audience, but the ones that we had made great contributions. And in particular, we found out it was hard to estimate parameters for the model, but we were successful. We had several people give us estimates that helped us move forward. Another thing we found out is that it was hard to do both a tutorial and an exercise during 4 hours. We had to drop a little bit of our agenda, but we were successful on the rest of it. We had some conclusions. The importance of estimating system engineering costs varies from organization to organization. Some people came in who were pretty knowledgeable about system engineering costs, and they said, well, it's always small. So they didn't need a system engineering model, but other people, were very interested in the results of system engineering cost model. And it also varies from situation to situation. The purpose of the model is to help both developers and acquirers, and we were, the model helps both groups of people. We learned that we might need to have different sets of parameters for different types of systems, like for different application areas, maybe government versus commercial, and so on. And then last, we learned something on, which was kind of expected. A learning curve is needed for the model. And I'd like to thank a couple of our people in the workshop. The phrase that occurs to me is they both did yeoman work in helping us out. The problem is that the phrase yeoman is not exactly right, because Sherry Stukes and Marilee Wheaton were the two that helped us out. So they, as guinea pigs, sat down with one with me and one with Barry, and we went through this brand new model on a brand new spreadsheet, working it out. And they were very patient with us, and they helped us out a lot. So we learned from their work. And one thing we learned is, at least in this situation with a prototype model and them getting expert advice, we could successfully go through an estimate, have somebody generate an estimate, somebody's familiar with the project. And I think we spent like 15 or 20 minutes only on that. So we take that to be a great sign of success. So I would also, again, like to close by just thanking everybody who contributed to us, and we did move forward.
Hello. Good morning. My name is Ramesh Rangachar. I am the co-chair of the session 11E, which is cloud computing for ground systems. The other co-chair is Dr. Craig Lee. The goals of our session was to examine the state of the art as well as state of the possible in the use of cloud computing and big data for ground systems. So we had talks from various presenters, and also we had discussion among the cloud system community. The aim was to see what's the impact of cloud computing and what's the impact of big data on ground systems. So what's the impact on the various, with the various elements such as the design, implementation, and so on, sort of the end-to-end life cycle. So we wanted to find out what are the potential benefits and what are the outstanding challenges. So we do want to understand, what are the issues that we are having in adopting cloud big data. So we had a representation from over 20 organizations. There were somewhere between 40 and 50 people. And you see the different types of organizations that were that participated. I do want to thank all the participants for attending this, our working group, and also for contributing to it. Here is the list of presenters. So as you can see, we had presentations from, UMETSAT, NASA, JPL, NOAA, USGS, and the Aerospace Corporation. Various topics were discussed. The presentations showed that there were solutions using the private cloud, solutions using the public cloud, and the hybrid cloud, and also cloud bursting. There were two presentations that were very interesting about the public and private partnerships to address big data challenges. One of them was from the USGS and the other one from NOAA. The use of big data for business intelligence was another presentation. Then there were also presentations on the future ground architectures as well as cloud federation management. Some key takeaways from the presentation. One of them was don't jump into cloud because it's popular. You want to make sure that it makes sense. Is it saving you money? Is it giving you reliability, or is it improving performance? So on. The other thing was about especially with the big data, the access to data can be slow, and that can become an issue. And there were discussions regarding how what you can do to bring computing to data rather than the other way around. From some of the presentations, it was clear that people, especially in the ground system, for ground systems, are preferring private clouds as opposed to public clouds, mostly because of concerns they have with ITAR. And when there is no concern with the ITAR for such data, they are putting it on the public cloud this way. They are trying to build a hybrid cloud. Issues and concerns, no surprise here. The biggest concern has been data security. So it continues to be the biggest concern. Of course, the others include governance, cultural barriers, policy issues, and so on. So you do have to find early adopters, and one of the most important things discussed was decoupling the infrastructure verification from the application. This was echoed this morning in Mr. Steve Peterson's talk, as well as in one of Mrs. Asa Campbell's talk when she was talking about separability as one of the tenets. I changed the title from conclusion to summary. So the main takeaway for me was that cloud computing and big data solutions are being implemented in ground systems, and there are still some challenges. The cloud and the big data will continue to provide innovative approaches for us to deliver ground systems. And this third one was mainly from the USGS and the NOAA presentations. There are a lot more opportunities that can be created. There are opportunities for public and private partnership, and there is a lot of data available that in order to realize the full potential of the data, there is partnership required between with the industry. Our focus for next year. People said that these are hot and evolving topics, and we need to continue a discussion. People wanted more implementation-specific presentations and more implementation-specific discussions, and also emphasis on non-technical aspects, cost analysis, and metrics. So, in summary, I know we heard during the panel discussion that the commoditization will take over everything. And we need your help in this working group as we move forward in next years. And we do want to have, an enterprise level ground system, and that uses cloud and big data before GSAW 2030. Thank you.
see, I'm the last guy on the panel, so I have to come up with new adjectives to describe our panel. So Catherine and I hosted 11F. That was the ground system enablers and future small-sat development. We started off with seeding a bunch of questions here. Basically, we were after what can't you do today? And largely on the small-sat side, because that was our emphasis. And what can't you do in missions, and what ground services would you need to do that? And, of course, then the loaded question of what are you doing about it? We invited a couple of panelists to discuss with us. We had a nice representation between commercial. We had NRO friends represented, AFRL and the Navy Spay War West called in, and Dr. Marco Vila, who's a commercial vendor of small-sat systems. We had what I would probably describe as a spirited discussion, because I don't think anybody else has used that adjective yet. Some key points that came out of the discussion, and this is by no means a complete list. The size doesn't really drive the ground system. It's really your mission needs and ConOps. You know, to a ground system, the spacecraft could be a CubeSat, it could be a Battlestar, and it's what you're actually trying to do that is important. An interesting thread of discussion we had is, are we in the Wild West in small-sat development? So we thought we wanted to put that on the chart as a wrap-up. In some ways, yes, in the R&D world, you are kind of in a Wild West environment. Constrained development cost-constrained development can actually drive your innovation. We hear from our university friends, you know, well, they're redesigning large parts of their system because they can't afford to buy a commercial solution. Sometimes you come up with an innovative solution that way, sometimes not. But it drives you to question your assumptions. There's an educational component of that can't be discounted. Sometimes it's not factored into the cost terribly well, and so it's sometimes hard to make an apples-to-apples comparison that way. But the education that drives, and certainly our panelists from Cal Poly can speak to that at length, is priceless. No for the advanced missions. The Wild West and advanced missions, that was 5 years ago or more. Right now, you have folks building very sophisticated small vehicles that are comparable in capability to some larger vehicles. You have megabit downlinks. You have 3-axis stabilization. You can do a lot of interesting stuff, and it's really just providing for your specific mission needs. O&M is expensive. We know that. Short-lived systems versus the long life, you don't have a tail that's driving your ground system that's keeping you funded. Automation, key enabler. So kind of a wrap up some conclusions. Small sats are very capable for supporting specific mission needs. You're not going to do everything. Physics is a driver. We can't always break those laws, but we try hard. Constellations was a big answer to the question, what can't you do? Constellations are tough. And by constellations, it's entirely possible now. ORS-3 dropped off 20-plus vehicles on one launch vehicle. That was about a year ago in October. So it's not out of the question when we talk about large numbers of vehicles. We could do that very rapidly. Small sats are inherently a disruptive technology. You've got very rapid development cycles. You know, fail quickly and learn. It is not uncommon or unheard of to have vehicles in the launch tube ready for launch before you have your frequency allocation paperwork in place. Variable funding challenges, long-term planning, we kind of know that. Standards constrain agility. Had a very interesting discussion on the standards and which ones you'll use. The joy of standards is there's so many to choose from. And one of the interesting things that came out is adapting large spacecraft ground solutions to small sats is not really feasible. And that was a theme that came from all of our panelists, that basically doesn't work well to move down that way. And so a lot of people are driving organic change to move up. But ultimately, it's not about the bus, it's about the mission and what the vehicles can do and provide to do a specific mission. Thanks.
All right, next on the agenda is Sam Cantrell with the workshop summary.
Well, this has been a really interesting workshop this year, and is our 19th GSAW. We saw that there have been several themes that have emerged out of these many years, and they are standards, the idea of open source, having a flexible, adaptive, agile, scalable ground systems. Cost control has always been a driver, and it used to be called just security. Of course, now it's cyber, and that sort of governs everything we do. This morning's keynote actually provided a nice bookend to the conference, because a lot of the challenges that he pointed out, again, were his deals with cost, cyber, and moving toward an enterprise focus. So looking at cost, as was mentioned, cost avoidance underlies everything we do, was a quote from this morning. And you sort of contrast that with one of the panel comments that contractors have to eat. So there's a natural sort of dichotomy between the two. And some of the comments along cost, having to do more with the same, much more, has always been a challenge here. And also looking at an opportunity here, rather than asking what we want, ask what do you have? So the idea that if you can leverage existing functionality from perhaps a larger mission, and you can live with that functionality as is, you can leverage it and save a lot in the area of cost. And being able to reuse systems by virtualizing, moving to commodity hardware, tailoring, basically trying to do more with what's already existing. And also that was brought out from the very first morning, the general mentioned that people drive cost. And if you can look at the concept of having humans on the loop rather than in the loop might be an opportunity to leverage that. One of the systems yesterday commented that they were afraid of automation for many years, but they finally did it, and they realized not only improvements in cost, but improvements in accuracy of system execution. Cost savings will have to be leveraged based on cultural changes, ConOps changes, and that's one of the big driving things. Is sort of, it's not the technical, as I pointed out. It's not the technical. It's the cultural. That's the big implementation to a lot of these. Looking at cyber challenges. So the idea that these satellites are around for a long time, and so that the tendency is to have your hardware from your ground system that matches that hang around for a long time, and that really increases your threats to your cyber. So because it leaves a lot of this legacy hardware and legacy protocols and whatnot. So the idea that you refresh when you should, not when you have to, is an important concept. And someone pointed out that you can't just protect your network. You can't put these things in place and just let them run. You have to watch the network. You have to have active participation in making sure these things work. Incident detection is important, but must be accompanied with incident response, as I guess the Target incident pointed out. Just because you know something's happening, if you don't have a plan to deal with it when it happens, you can just sort of watch the house burn. Also looking at this concept of partitioning data, that data access control, having sort of a need-to-know basis of partitioning who can see data, who has access to data. And as the journal pointed out the first morning, a space used to be just a purely strategic domain that was only open to superpowers. Now it's commercialized, it's open to all, and it's always in the fight. And the idea in the sort of subtitle there, challenges, everything in space is a target. It's a big high visibility resource, and everyone's gunning for it. And of course, we're all moving to enterprise. And the idea that we can't do this great thing we want to do with the existing architecture. I think that's obvious to everyone here is in agreement on that. We have lots of big picture enterprise vision, and as our keynote this morning mentioned, that we will never again buy another standalone ground system. But that's interesting because we have the cultural challenge of that's not the funding model. The funding model flows down in these silos, and so there's an actual cultural shift there, an opportunity to redesign the cultural aspect of it. So you're looking at common functionalities. Some of the studies were pointed out that approximately 60% of all our ground systems share a common functionality. And even the unique functions in those, in the remaining 40%, have a lot of commonalities. And ESA, which is maybe a little bit farther down the road in this than we are, they only have 10% of their typical ground mission is mission specific. And as pointed out earlier, technical challenges are easy. It's the cultural, the governance, the people part of it that are the challenging part. And looking at governance, what can you extend, accept, create? So how can you leverage what exists, much like the other technical stuff? And as one person pointed out, if you think commercial is better, you haven't worked with commercial yet. He also pointed out that their goal is to provide a fully stocked and instrumented kitchen for the chefs to create their recipes in. Also, you have to measure improvements, performance improvements by orders of magnitude. So rather than just saying, oh, we have a 10% improvement, you have to really have something in order to make it something that the user community will notice. And as we see a lot of agreement here, and I think it points out that for the first time it appears the stars are beginning to align. I think you said that. So we're really getting a time when we're getting a critical mass, when this move to enterprise might actually come about. So just some random observations. Looks like CubeSats are ubiquitous once again. The JPL AMOS system was first briefed GSAW in '97. Now it's in use and it's the starting point it's a building block for future innovation. GMSEC was also mentioned first at GSAW in 2003. Quote here, the sacred cows make the best burgers. I think that was sort of funny. The idea of failing fast, it's great to be first, but being the second person in is equally as important. And we have these common stovepipes. Test Like You Fly, again, was big. The age of space cyber attack is here, so something to look at there. And there are predictions for GSAW 2030. And my prediction for GSAW 2030 is that we'll have some presentations about how we can break up this large enterprise monolithic software system and be able to leverage these cylinders of excellence that we can use to gain better security or something. Anyway, thank you, and join us at GSAW 2016, which will be February 29th to March 3rd. And I think we have a thank you here. Here's Navneet.